Hi everyone, let's start lecture 12 and it is about integer programming. This lecture will be presented in two parts and this is the first part. We are going to have two case studies. So the first one, which is about optimizing hotel selection, will be covered in part 1, this part, and the class assignments will be covered in part 2. On the course map, we are in the prescriptive analytics models. We covered the linear programming in the previous lecture, and in this lecture, we are covering integer programming. Okay, let's go through the optimizing hotel selection case study. In this case, we are talking about the La Quinta Mater Inn, which is a mid-sized hotel chain headquartered in San Antonio, Texas. This hotel chain wants to expand to more locations. As you know, in the marketing mix, we have 4 P's: product, price, promotion, and place. We can say for a hotel chain, the place is more important than other P's because picking good sites quickly compared to a competitors would be a competitive advantage. Okay, so in this case, we want to help La Quinta Mater Inn to find better sites to expand the hotel chain. Okay, this hotel used data on 57 existing locations to build a linear regression model for profitability. So when we talk about the profitability, we mean operating margin before interest and tax divided by the total revenue. Okay, so in this linear regression, we see a perfect relationship between the profitability and the features of the hotel and also the features of the place, the location. So as you see here, we have 4 independent variables: state, population per n, price of the n, and square root of the median income of the area and college students in the area. So one feature, which is the price of the n, is the feature of the hotel, but the other 3 independent variables are about the location: state, population per n, square root of the median income of the area, and also the college students in that area. Before applying a linear regression model here, all independent variables were normalized to have mean 0 and a standard deviation of 1. Okay, and this is a perfect example that relates a predictive model to a prescriptive model. So here we are going to directly use this linear regression model in our optimization model because we want to somehow maximize the profit. So we'll use this linear regression model in our objective function. Okay. So according to the linear regression model that we have here, we see that the price of the n, let me write it here, the price of the n and the college students in the area, the college students in the area. These two variables have positive relationship with the profitability. So, and it makes sense, right? Because increasing in the college students in the area would increase the accommodations nearby the town. So, because of that, there will be more demand for the hotel, right? And also the price of the inn. Here we are not talking about the price of booking one room for one night. It's not that. It's the total price of the hotel. So higher price would mention that that hotel has higher features as well, right? It's somehow a luxury hotel, so it makes sense that the profitability would be higher for that hotel as well. And the variables of state population per n, state population per n, and also a square root of the median income, a square root of median income in that area and in the area. These two variables have negative impact, okay? And so maybe the only thing that doesn't make sense here is having a negative relationship between the state population per n and the hotel, but maybe it also makes sense, because if we have a highly populated area, that means maybe there is no need to hotels. And also the square root of the median income in the area, also if it's high, it mentions that the people living in that area are more wealthy. So because of that, again, there will be less demand for the La Quinta in hotels because of the competition, right? Because this hotel chain is not a luxury hotel chain. So yeah, this is our somehow observation. It makes sense somehow intuitively about the relationship between the profitability and the variables. Okay. So the La Quinta hotel chain wants to investigate California for expansion, and they have 16 different locations as candidates. Okay, so the variables, I mean the data about the variables have been collected. We have the data in table 1, and here we need to be careful that the independent variables are normalized. They are not referring the actual value here. They are normalized. So now we want to see what's the predicted profitability of hotel 1, and which hotel has the highest or the lowest predicted profitability. So let's see. Okay, here is the table 1. As you see here, for each location, we have the actual price. Let me highlight here. Yeah, we have the actual price, and then it's converted to be normal with mean 0 and standard deviation of 1. So we have the price as normalized, and other columns or variables here are also normalized. Okay, so now for each location, we can apply the linear regression model that we have in order to obtain the predictive profitability. Okay, so as you remember, our linear regression model has an intercept of 39.05, right? And then the price has positive relationship, so plus this price should be multiplied by 5.86, okay, this column. And then the square root has a negative relationship with price, so, and its coefficient is 3.09, so this is multiplied by the value in this column. And the college student again has a positive relationship, and its coefficient is 1.75, so this is multiplied by this column. And at the end, the state population per n has a negative relationship, and its coefficient is 5.41, and this is multiplied by this column. And at the end, we would have the profitability. Okay, the predicted profitability for that location. For example, for hotel 1, it becomes 44.24. Okay. And the hotel 2, which its price is $10 million here, would have the highest predicted profitability, and its value is 53.38. Okay, and hotel 8, this one here, its profitability would be 23.45, and this is the least predicted profitability. Okay, so as you see here, we can apply the linear regression model, and we can calculate the predicted profitability for each location. Then we can use those predicted profitability as the coefficients of objective function, and then we can easily formulate our objective function here, and then we should see what are the constraints, and then we can build our model, and then by solving that model we'll obtain the optimal solution here. Okay, now suppose that we have $10 million as our budget to purchase the new hotels. So let's assume that we want to apply a greedy approach here. The greedy approach would work like this, selecting the most profitable hotels until you run out of budget. So if we apply this approach, then we would start by selecting the hotel 2 because that one has the highest profitability, and since its price is $10 million, so we stop there. We run out of the budget. So by this approach, we just buy the hotel 2, right? And its profitability is 53.38. 53.38. But if we want to maximize the total predicted profitability, then we can say this approach is definitely not optimal, because we can do much better by selecting cheaper hotels, several cheaper hotels, but in the total we would have more profitability than buying just one hotel with the highest profitability. Okay, and how about maximizing the average predicted profitability of selected hotels? If you apply this approach, then it would be optimal. Okay, and how about having a budget of $20 million instead of 10 million? If we have $20 million after hotel 2, we would buy hotel 6 as well. Hotel 6, and the total profitability would be 102.47. Okay, so now we want to do better than this greedy approach, and the solution is building an optimization model. So we are going to build an optimization model here, and our decision variables would be binary variables. So because of that, we would have an integer programming model with binary decision variables. Okay, so now let's build an integer programming model here. The objective function would be maximizing the total predicted profitability. So here, if we define the decision variable of xj as binary 0 or 1, so 1 would be buying the hotel in that location xj, and 0 would be not buying that. So the objective function here would be sum over j going from 1 to 16, so because we have 16 locations, right? So the coefficient would be the profitability, which is obtained by the linear regression model, profitability of j times xj. Okay, for example, the first location has the predicted profitability of 44.24 times x1, plus the second one has 53.38 x2 plus, and so on. Okay, so this would be our objective function, and for the constraints we just have one constraint here, which is this our budget. So the sum over j going from 1 to 16. And if we have the price, let's call this as pj, the price of the hotel in location j, times xj would be the total budget the total fund we need to have here, and our budget is just $10 million. Okay, so this would be our only constraint here, and now we are good. We can implement this model in any optimization solver in Excel or in R, and we can use the LPsolve package to obtain the optimal solution. If we do so, the optimal solution would be buying the hotels in locations 5, 10, 11, 12, 13, 15, and 16. 1, 2, 3, 4, 5, 6, 7 hotels. Okay, and the value of the objective function here would be 269.92, which is much better than 102 that we had in the greedy approach. Okay. So now suppose that the hotel wants to diversify the hotels across as many cities as possible. So because of that, here we have more constraints. So our constraints would be this based on the constraints obtained by the hotel. We have x2 plus x3 plus x4 plus x5. This should be less than or equal to 2. Okay, and we don't want to have more than 2 hotels in same city. Okay, so and then x7 plus x8 plus x9, this should be again less than or equal to 2. And the last one, x10 plus x11, x12, 13, 14, 15, and 16, this should be again less than or equal to 2. So if we add these 3 new constraints in our model, we should expect an optimal solution, which would be definitely, in terms of the optimal objective value, would be definitely smaller than before, because we are imposing more constraints and the solution couldn't be better than before. Okay, so if we implement these 3 new constraints in the model and resolve the model, the optimal solution would be buying the hotels of 1, 5, 7, 8, 10, and 11. 1, 2, 3, 4, 5, 6 hotels. Okay, and the Z star, the optimal objective value, would be 205, less than before, as you see here, 205.70. Okay. So at the end, for the discussion, we can represent our results to the La Quinta Hotel by first showing the original optimal solution, and then we can show them how the solution changes by adding those 3 additional constraints. Okay, and also we can order the hotels by their predicted profitability, and then we can explain them why we're skipping the hotels with higher predicted profitability, because they are not worth the price. Okay, and to improve the linear regression model, we would recommend collecting more data to train the model with a larger size data, and also try to add more independent variables. Okay, and also for improving the optimization model, we can make sure that all necessary constraints are included. And also if we have more potential hotel sites, we can add those ones into the model as well. Okay, thank you.